let's just move on further. As we know that any linear equation in two variable can be represented as ax plus by plus c is equal to 0. This is actually the journal equation or the journal form of the linear equation in two variable. So let's just talk about its geometrical representation. How we can geometrically represent the equation ax plus by plus c is equal to 0. So first of all, the polynomial equation obviously is called as a linear equation in the two variables. Ax plus by plus c is equal to 0 is called as a linear equation in two variable. It's a geometrical representation. Always remember the geometrical representation of the linear equation is always a straight line. It is always a straight line. So let us suppose if I'm talking about its geometrical representation, then this yellow line is nothing but called as a linear equation in two variable. Ax plus by plus c is equal to 0. So this yellow line is actually representing the geometrical representation of ax plus by plus c is equal to 0, which is nothing but a straight line. So it can be of any form. Let us suppose if I've taken it as in this oblique form, it can be a straight line, it can be a horizontal, a vertical, it can be anything. But always remember, it is always a straight line. It is always a straight line. So let's just see this representation, this geometrical representation with the help of an example. So let us suppose if we are talking about the graph of a linear equation in two variables, we are now taking or plotting the graph related with the linear equation in two variables. So let us suppose if I am taking an example of a linear equation in two variable as x plus 2y is equal to 6. We have x plus 2y is equal to 6, and now we will represent the graph of this linear equation in two variable. So first of all, we have to find out the solutions. Always remember, in order to represent it graphically, we have to find out the solutions of this linear equation in two variables. So let us suppose in order to plot the graph, we are finding out the first solution as x0, y3. If we'll substitute x as 0 in this particular equation, we will get the answer as y is equal to 3. We already know how we can find x0, y3 or the solution of this particular linear equation. So x is equal to 0, y is equal to 3 is the first solution of the linear equation. Let us suppose if I'm finding out the second one as x is 2, y is 2. Obviously x2, y2 is the solution of this linear equation in two variable. Furthermore, I'm finding out the third solution as x6, y0. This is also the solution of this equation. Furthermore, x is 4, y is 1. This is also the solution of this particular linear equation in two variables. So I am taking 4 solutions in order to plot the graph of this linear equation in two variables. So let's just take a graph. Let's just take the graph paper, and on the graph paper we are plotting the points with the help of the Cartesian plane. Let us suppose we are taking the Cartesian plane, x dash, y dash intersecting each other at the point O. We definitely know how we can plot all these points. So let's just start with the very first point. We have x0, y4. x0, y4. So x0, y4 means x is 0. If x is 0, it means the point is lying on the y-axis. x0, y3. So this is nothing but 0, 3 coordinate. So this is my first coordinate. x2, y2 is my second coordinate. So x is 2, y is 2. x is 2, y is 2. So this is 2, 2. Further, x is 6, y is 0. x is 6, y is 0. So further, this is x is 6, y is 0, and this is 4, 1. We are taking 4, 1 first. X is 4, y is 1. X is 4, y is 1. So this is the point 4, 1. This is the point. Next point is nothing but 6, 0. This is nothing but 6, 0. So let's just join all these points all together. Let's just join all these points all together. We are getting this straight line. This red straight line is actually representing x plus 2y is equal to 6, which we can see is nothing but a straight line. So this is the geometrical representation of x plus 2y is equal to 6, or we can say that the graphical representation of x plus 2y is equal to 6. So I hope the graphical representation of this particular linear equation in two variable is all clear to you. So let's just further talk about the observations that are related with this particular graph. So what can we conclude from this particular graph, or after looking at this graph, what we can conclude? So let's just talk about the very first point. We can conclude that every point whose coordinates satisfy x plus 2y is equal to 6 lies on the line AB. Always remember that each and every point that is lying on this straight line, each and every point that is lying on this straight line is actually called as the solution, of the equation x plus 2y is equal to 6. It means every point that is lying on this equation, every point that is lying, as we know that there are infinitely many points that are lying on this red line, so all these points are satisfying this particular linear equation x plus 2y is equal to 6. So always remember, every point whose coordinates satisfy x plus 2y is equal to 6 lies on the line AB. Furthermore, we can say that every point a comma b on AB gives a solution. So every point definitely gives a solution, because we are saying that every point is a solution. So every point is represented or can be represented in the formation of x is equal to a, y is equal to b, of x plus 2y is equal to 6. So the third point is nothing but any point which does not lie on the line AB is not a solution. It is quite obvious thing. Any point which is actually not lying on this particular line, let us suppose if we are talking about the coordinates of the origin 0, 0, as 0, 0 is not lying on this line segment AB, or the line, it is not a line segment, sorry, it is not a line segment, we are talking about the line total AB. So if it is not lying on this AB line, it means that it is not a solution of the equation x plus 2y is equal to 6. So always remember, if any point does not lie on the line, it is not a solution. And on a line there are infinitely many points. It means that the line do have infinitely many solutions. So these are all the three observations that we have concluded from this particular graphical representation. Now let's just move on further, and let's just further talk about the graph of a linear equation in two variable. Example number 1 says, draw the graph of x plus y is equal to 7. So in the same way like we did before, we just wanted to represent this graphically. So we have to find out the solution of this particular linear equation. So let us suppose if I am taking the graph first, and let's just find out the solution. Substitute the different values of x and y. So this is my Cartesian plane. Let us suppose first of all, if I am taking x is equal to 0. If x is equal to 0, then 0 plus y is 7 and y is equal to 7, means the very first solution is 0, 7. The very first solution is 0, 7. Further, the second point is, if I am taking y as 0, then x plus 0 is equal to 7 and x is equal to 7 means 7, 0. It means we have two solutions, that is 0, 7 and 7, 0. So with these two solutions, I'm just plotting the graph of x plus y is equal to 7. We can take 3, we can take 4, we can take 5. So I'm just taking 2, that is 0, 7 and 7, 0. With these two, I'm plotting the graph. So 0, 7 means it is lying on the y-axis, and 7, 0 means it is lying on the x-axis. So I'm just plotting 7, 0 first, and further we have 0, 7. We have 0, 7. So this is my 0, 7. So this is 0, 7. This is 7, 0. Let's just join these 2 points all together. So this is nothing but the line. So this is the graph of x plus y is equal to 7. This is nothing but the graph of x plus y is equal to 7. So with the help of these two coordinates, I have actually plotted the graph of x plus y is equal to 7, which is nothing but a straight line coming out to be as this one, as this straight line. So this is x plus y is equal to 7. So let's just move on further, and we have also written over here as x plus y is equal to 7. It is always good to write the equation on the line as x plus y is equal to 7. This is the equation of this line. Now let's just move on further to the example number 2. Example number 2 says, you know that the force applied on a body is directly proportional to the acceleration produced in the body. Write an equation to express the situation and plot the graph of the equation. So let us suppose if we are starting with, according to the question, it is all mentioned to us that the force applied to the body is actually directly proportional to its acceleration, which is already given to us. So let us suppose, let the force applied is nothing but y, by, or let the acceleration be x. So according to the equation number 1, we can represent it as y is directly proportional to x. Y is directly proportional to x. We can write it in this particular form. Moreover, if y is directly proportional to x, then we can write it into the formation of y is equal to k into x, where k is any constant. So it means you can take any value of k if you want to plot the graph of y is directly proportional to x. So let us suppose if I am taking k as 1, so let if k is equal to 1. So let if I am taking k as 1, you can take k as 2, you can take k as 3. Let us suppose if I am taking k as 1, because k is any constant, then the graph will be, or the representation of the equation will be of the form y is equal to x. It means that I have to plot the graph of y is equal to x. If you will take k as 2, then you have to plot the graph of y is equal to 2x. So I am taking y is equal to x. So let's just start taking the solutions of this particular equation. Let us suppose if I am taking x as 0, then y will be 0. If I am taking x as 1, y will be 1. If I am taking x as 2, then y will be equal to 2. If I am taking x as 3, then y is also equal to 3. It means the coordinates will be 0, 0, 1, 1, 2, 2, further 3, 3. Furthermore, you can find 4, 4, minus 1, and so goes on. So these are all the coordinates of the graph which is related with y is equal to x. Now let's just plot the graph. Let us suppose we have this particular graph. We have this graph and we are taking the xy particular plane in this form. So let's just plot 0, 0 first. So this is my 0, 0. This is my 1, 1. This is my 2, 2. Let us suppose I'm taking 2, 2. This is my 3, 3, 4, 4, and so goes on. Let's just join all these points all together. So at the end, if I'll join this points all together, I'm just taking only 2 points. You can take more than these. So all these points when joined together, this will give the graph of y is equal to x. As I have taken k as 1, you can take k any particular value. So this is nothing but the graph of y is equal to k of x in case when k is nothing but 1. So this is all about representing when the situation given to us that the force applied on the body is proportional or directly proportional to the acceleration. So this is all about the plotting the graph of y is equal to k of x in case k is 1.